So we do one more technique on the mensuration based on the 3 circle combinations, and in between them 1 circle is also again inserted. Just I want to remind you once that even we have done this 3 circle combination for circles of equal radius previously, but we are asked to find out just the space in between them. That means if the absence of this white circle, if space will be there, no, that is 0.16 r square that we find in the previous case. But here one more case is again involved. What is that? Here we have given the radius of each bigger circle is capital R. Here this is how much? Capital R. Okay, radius of each bigger circle is capital R. And we need to find out the radius of small circle inserted between them. I think you can identify here small circle which is given in between them, which is touching all the 3 circles. Okay. For that we need to find out the radius. Okay, see guys, everything can't be done directly. Okay, everything is not that easy. We need to do the analysis for the diagram, and then we can thereby we can obtain the answer for this question. Okay, and by obtaining the final result we can do the exercise on that in next video. Okay, so first of all we need to obtain the value of radius of this small circle. For that we need to do some analysis of the figure by doing some additional construction for that. Let us do that. Okay, let us suppose I am taking 3 centers of the circles. Okay, joining the 3 centers of the circles. Okay. Now we have constructed, we have joined the centers. This is a center and this is a center and this is a center, and we joined all the centers together like this. So here one triangle is formed. As from the previous cases we know that this triangle is equilateral. Why? Because all the radius of the circles are same, equal. When radii of the all circles touching each other are same, then definitely triangle formed will be equilateral. Okay, and one more thing, let us write down the radii of each circle. Okay, radii of each circle would be, see, for this capital R as given in the question, and this would be capital R, and this would be capital R, and this would be capital R, and this all are radius are equal. That's the reason behind this is an equilateral triangle. First thing is over. But still it is not sufficient to solve this problem, because it's very difficult thing to find out the radius of this center one. In order to find that, here we need to do some additional construction. What is that? Let us see. Here these 2 circles are touching each other or not, and here also they are touching each other or not, and here also they are touching each other or not. At point of contact on the sides of the triangle, okay, those are points located over there or not. Now let us do one thing. We join the vertices of the triangle with this point of contacts of the circles, means like this point. Okay, and this point and this point. Let us do that. We do this construction. Now we have joined this vertices with this points of intersections, points of contacts of the circles, means touching point of the circle on the side of the triangle. Got it? This part we have drawn now for our requirement. Now let us do some more thing. So we have to find out some relation for this circle radius. So here we can't analyze on the diagram because it is looking a bit clumsy. Let us take this to outside. Okay, and then we do something, and then we do analysis part of that. Let us see. Now we have, we took this to outside to observe the properties of that. What are that? Let us see. Here first of all observe, here all the radius, this is a radius, this is also a radius, okay, this is also a radius, and this, all the lengths are equally divided. That means for this side, is this a midpoint or not? Tell me guys, is this a midpoint or not? This point is a midpoint or not? Midpoint. So these two lengths are certainly equal. Similarly, here also this is a midpoint or not? Then this is also, these lengths are also equal. Next, this is also a midpoint, then these lengths are also obviously equal. The first thing we got from this figure which we have drawn. Now next part. Now just observe this line. This line is drawn from vertex to midpoint of the opposite side. See this midpoint opposite side, and this is vertex. Okay. So when this is drawn to midpoint, this type of lines in triangle are called medians. What do we call that? Median. First thing is what? Median. Okay. That how it is median and what are medians we'll discuss in the topic of geometry, but we are using the result here. Okay, now so here this is also median, this is also median. Okay, so these three are the three medians for this triangle obtained here. First thing. The next thing, when these three are three medians, okay, when these three are the three medians, okay, in case of equilateral triangle, once again from the basics of geometry, in case of equilateral triangle, for equilateral triangle, median is perpendicular to the side. Median is perpendicular to the side. So let us suppose this is perpendicular to this side, and this is perpendicular to this side, and this is perpendicular to this side. I am telling you guys, in every type of triangle, like for scalene triangle, for isosceles triangle, median won't be perpendicular to the side. It is only happens in equilateral triangle. Why it happens, I'll explain to you there in geometry topic in very detail. But here let us use this technique. Okay, let us use that property. What is that property? Median of equilateral triangle, each median of equilateral triangle is perpendicular to its side. That's first point should be clear. Next, when it is perpendicular, I want to explain you one thing more here. In any triangle, any kind of triangle. So for example, I am taking a bigger triangle. Okay, in any type of triangle, you take, for example, like this kind of triangle there, from line drawn from vertex to opposite side. Line, not line, perpendicular drawn from vertex to opposite side is called as height or altitude. What do we say? Line drawn from vertex to opposite side, not line, perpendicular drawn from vertex to opposite side is called height or altitude. In this case, what happened? Here median is also this line, and hence it is perpendicular to the side. It's also altitude or not? It's also height. So here what we can say here is, from basics of geometry, okay, height and median both coincides for every side in an equilateral triangle. So this is a median or not? Yes, median. This is a height or not? Yes, height. Both are the same line. First thing that should be clear for you. The second thing, height of the equilateral triangle, how can we find from the mensuration basics? Okay, mensuration basics we can teach here. Okay, height of the triangle, how can we find for equilateral triangle? This is an equilateral triangle. See, I'll tell you basic formula. Once again, remain you. Okay, if side of an equilateral triangle is A, then its height would be root 3 2 times of its side, means root 3 by 2 A. For you people, it's clear or not? Okay, which will be taught to you in your basics of the equilateral triangle in mensuration part. So when side is given, then height or altitude is root 3 by 2 times of its side, that is root 3 by 2 times of A, right? So let us go for next. So from this, what can we find? Here, what is every side? What is the length of every side, guys? Is this combination of 2 radii or not? So this would be 2r. Similarly, this would be 2r and this would be 2r. So all the sides equal to double the radius. First thing is that. Now, what can be its height? So is this its height or not? I am telling you here. Is this height or not? So this height can be what? This is height. So this height is root 3 times of its side or not? Root 3 times of 2r or not? Because 2r is side. So root 3 times of, root 3 by 2 root 3 by 2 times of its side. Side is 2r. Further it can be cancelled. So what should be the height of the triangle? Root 3 or not? Finally it is root 3r. What is the total height, each height of the triangle? So this length would be root 3r. This length would be root 3r. This length would be root 3r. That's the first thing we have to find. Okay, here we are finding these all things only to find out the radius of this small circle, which is highly complex. First of all, we need to do analysis of like this. Okay, now what is the height value, total height value? Root 3r. So that means this entire length. Now let us know one more basic about the medians. See, it's a height and it's median also, because both are coincident in case of equilateral triangle, that I said you before. Okay, now here this is a point of concurrence of all medians as well as all heights also. Point of concurrence of all the medians is centroid. What do we call this? Centroid. Of course, it is represented by capital G, and it is not a point here. Here G divides every median in the ratio 2:1. From where 2 parts and from where 1 part? From vertex to centroid, 2 parts of the distance will be covered, and from this to here, from here, from this to side, 1 part will be covered. Like means this is 2:1 in the sense this is 2 parts and this is 1 part. Not only for this also this is 2 parts and this is 1 part. For this median also this is 2 parts and this is 1 part. Clear? So now we need here this much of distance. We want to find here what? This distance. Means this centroid to this vertex distance. Why I am finding, I'll explain to you later. Okay, how to find out this distance? Total height is how many parts here? 2:1 means 2 plus 1, 3 parts or not? Okay, and here how many parts are covered? 2 parts. So out of total height, what part is covered from this to this? 2/3 or not? And here 1/3 part is covered or not? So here out of total length, 2 by 3. I'll tell you. See. So here, out of total height, it is covering 2 by 3 times of total height. What is total height we obtained? Root 3r. So here, total height root 3r to that 2 by 3 times, and here 1 by 3 times. Of course, we don't need that. We don't need that value. Got it? So now, what is the value of this? 2 root 3r by root 3. 2 root 3r by root 3, which is nothing but what? This value I am writing here. That is 2 root 3r by 3. Means what we find finally, out of this all, we don't need all this. But to get the radius of this link is required. Which length? This one. Why I need this length? I'll tell you later. Okay. Now, let us see. I'm once again explaining you. What is this 2 root 3r by 3? Is this length of this much segment or not? So, for length of this segment would be 2 root 3r by 3. Clear? Now, let us go to next part. Now, what is this? This length is 2 root 3r by 3. Why I find like this? Okay, just see. Here, actually in this diagram, okay, this is a circle or not? Obviously circle. Now, I want to ask you one more thing. See, in this, is this a radius up to this point? Is this a radius or not? Tell me, is this a radius or not up to this? Radius only, no? Because from center to the point on circumference, this distance is nothing but radius. Okay. And this total distance we find now. Okay. Now let us draw this on the board. Is it a part of circle or not? If you continue this, this will be circle, right? So this is a part of circle. And now here small circle is located. Now what is our try? See, I am plotting here. I will show you the variation also. Just see. So from here to here, this total distance is how much? Now only we said that 2 root 3 capital R by 3. This is entirely this distance. Now we, from the figure we analyzed, this distance is how much? R or not? So now this is R. Just listen to me guys. Here this total distance is this much and this distance is this. Then difference of these two, see, up to here, this total, from this total distance, if you subtract this distance, then can we get this length or not? What it is exactly? Is it a radius of small circle or not? That's it. We need to find that one only. So here total length of this one is 2 root 3r by 3 minus, we need to subtract the r. So what do we get here? 2 root 3 by 3 minus r. So on taking LCM and taking common r from this, we can get this. Finally, if you want to take the LCM also, you can take taking LCM, this 3 can be goes to that side. So now I'll write here. Finally, what would be its value? 2 root 3 minus 3 by 3 into r. So this is a finally radius of this small circle drawn inside. Once again I am telling you here, this is a total distance which is 2/3 of the height. That value would be 2 root 3 by 3 r, where r is the radius of each circle. That's the first thing. And then we have from the figure analysis, this from here center to this point on circumference, this is radius. So this is radius. This is 2 root 3 r by 3. So the rest portion from this whole length, if you subtract the radius, then we get the radius of the smaller circle or not. That's our question. So what we find here, 2 root 3 r, 2 root 3 minus 3 into r. So finally, okay, anyways, this is the analysis part. Leave about the analysis. Finally, those non-math students who want the answer directly, what is your answer then? Finally, 2 into root 3 minus 3 by 3 into capital R, where R is the radius of each bigger circle. Let me write this once again. Okay, so finally, leave about all the confusions that I explained to you only to know the complexity in the problem. But finally, if you are unable to do this all the process, just remember that result only. What is that result? Tell me. Whenever we have given a combination of the three circles, where all the circles are of equal radii, and each radius would be some capital R, where this is capital R and this radius is capital R and this radius is also capital R, where all are of equal radii of capital R. Then if small circle inserted between them such that it touches all the three circles, then radius of this will be how much? That radius of this will be 2 root 3 minus 3 by 3 times of bigger radius r. This is your final technique, which is very smartest, because we have done the analysis up to 15 minutes, then we got this result. If you can remember this, you can solve the problems very easily. Within a fraction of seconds, you can just putting the value of r, you can get here small radius, isn't it? So try to analyze the things, and I'm telling you guys, don't just, even though this is a technique, don't follow blindly. Okay, just go through the analysis and then after finally keep this result in your mind, because we can't do the analysis in the time of examination, because we don't have it time more than 1 minute for a bit. So at the time of examination, you just simply can substitute the value of bigger circle radius, and then we can get the value of small circle radius. Hope you guys would have enjoyed this technique in the mensuration.